Okay, good afternoon everyone. I am Trevaskis from EcoDrive. EcoDrive is an electric vehicle consultancy which I founded around 8 years ago, which was really quite early on in the days of electric vehicles. My background in this is that I was a customer. I actually ended up buying an electric vehicle myself, and that kind of spurred me on to think that there was a business opportunity in it, but that other people would be interested in it. So I'll come back to that in a sec. So basically, just a quick agenda of what we'll look at today. So an understanding of who EcoDrive is, and really what the electric vehicle marketplace, particularly in the UK and Europe, is looking like right now, and looking at the government's role in that, particularly with regard to incentives and charging infrastructure. It's the whole classic chicken and egg situation between vehicles and charging points. But really looking for what you guys are going to be interested in is looking at how electric vehicles will affect or positively benefit the grid, both in the UK and in other parts of the world, and what challenges and opportunities there are to do with that. And yeah, we won't touch too much on the last thing, but it's just really to look at the future. It's still early days in the electric vehicle world, so we'll see where the future may lie. So that was my first foray into electric vehicles 14 years ago. It wasn't an overnight success. I was conscious of what was going on, particularly in California at the time in '99, with regulations around air quality and the burgeoning market for electric vehicles. So I thought, okay, well, I'm interested in this. Is there something out there for me? And I found one of these at a dealership in Bristol when I was doing my postgrad, and decided to go and have a look at it, and rode it around the car park. Nearly fell off. I can still remember the look on the seller's face. But I didn't go back and buy it straight away. It was actually only about 6 months later when I went to look at a used car, and I happened to pass by the dealership and it was still in the window. So I decided to give him my hard-earned money, which basically wiped me out. There's no eBay at this point, so it's like, if this thing doesn't work, then it's just going to go and sit in the corner, and I've just blown a load of cash. But it did work, and I'm glad to say, and I found a business from it. So fast forward to 2005, and we bought a fleet of electric cars and vans and started doing various demonstration projects with them around the southwest, and in London as well. London was a burgeoning market there on the international scene. So very small scale. The technology in these really doesn't compare to what the vehicles are capable of doing today. But still, nonetheless, there were practical vehicles. There were more of these in Europe than there were in the UK. But yeah, we had various public sector customers trying the vehicles. Devon Green Police tried a vehicle. It wasn't a Blues and Twos vehicle. It was doing a support role. But everyone was keen to try it just to see how the vehicles could work for them. Fast forward to 2010, and we were seconded into Cornwall Council because there was a government push to provide infrastructure. So they were looking for pilot areas in the UK to give money to blanket them with infrastructure to challenge the preconception that it's a chicken and egg. If you don't have, nobody's going to buy a vehicle until you've got something to charge it, but there's no commercial case of putting in charging points until you've got enough vehicles to support them. So we helped Cornwall Council devise a bid to Westminster, and they also went out and bought some Nissan Leaf vehicles on our recommendation, which are still being run. They're being run again in a constrained circumstance. They're being used practically by the planning offices, and we didn't get the bid. I'll come back to why in a moment. But my business partner Tim and I, we went on to use our expertise to help the vehicle manufacturers. The vehicles were brand new at this point. Nissan Leaf, Peugeot Ion, Citroën C0, these were all brand new vehicles. And apart from having 4 wheels and a steering wheel, they were very, very different to everything that had come before. So even the vehicle manufacturers didn't really understand them that well, or there were very few people that did. So we helped dealers and the manufacturer staff to understand their vehicles and to see what potential they would have. Renault to date have probably invested the most in Europe of any electric vehicle manufacturer in the order of €4 billion to develop a range of different electric vehicles, one of which is the one we've got downstairs. So this actually looks like it's photoshopped, but it's not. This is actually the launch in Seville a couple of years ago for Renault's whole electric vehicle range. So that's just a summary of who we work with as a consultancy. So we work with the vehicle manufacturers, but then we also work sort of from the demand side. So we look at, we support those organisations who are looking to use vehicles or who may be able to influence others to use them. Early on, we don't use such as now, early on we published some technical papers about recharging and it was about the evolution really of charging points and what we needed to see to make charging convenient and safe. And this is still a moving feast. There's still a lot of development work to be done here, but it's pretty well defined. So just over 2 years ago, we ran what turned out to be quite a groundbreaking event at the Eden project, just up the road, when we had all the vehicles that were on the market at the time for people to see, often for the first time, but also they could drive them as well. And we had people coming over, and we were quite impressed that a few people knew a fair bit about the cars, but when we actually offered them the chance to drive them, albeit only on site, we did break a few speed limits, they were blown away by it. And so we sent people away having been effectively being educated about electric vehicles and what they could do, and it did change people's preconceptions about electric transport. So lots of conversations, lots of myths. You don't win everyone over, but with the new technology that's to be expected. So looking at the vehicles that are around currently, and this is still very relevant. Nissan Leaf really started it all and is still the benchmark really by which most electric vehicles are judged. So it's about the same size as a Ford Focus or a VW Golf, that size of car, 5-seat car. It's very contemporary. I mean, this is actually an older picture. This is from the first generation car. It's just been changed. It's now produced in Sunderland as well for the whole of the European market. This is just a quick slide about the battery that sits under the floor in the Leaf, and we'll come back to this later because it does have a relevance on energy, on grid management. But the battery is actually made up from cells which are about the same size as a laptop, and then they're stacked in different configurations to fit under the floor of the car. So the tallest bit at the back there is under the back seat. That's quite typical of how electric vehicles are designed. This is the Mitsubishi Leaf, which is a much smaller car. It's just a 4-seater car. Its closest thing would be to think of it as a stretched smart car. So it's rear drive, so the drive wheels and the electronics in the back. So it's very much the same as a stretched chassis smart car. Again, it's a much lower level car. It's a much more entry level car compared to something like the Leaf. Not to say you can't have some toys on it. This is the Peugeot 1. If it looks remarkably familiar, it's because it basically is the Mitsubishi. So not unlike other cars, there's actually very few distinct cars out there in the world. And more often than not, cars are what's called badge engineered. So you take an existing car, you whack your own badge on it, or maybe you've developed a car together, and then you go off and do something slightly different, but effectively underneath it's still the same car. That's actually a pretty good way. Peugeot and Citroën both took Mitsubishi's car and put their name and badge on it. So, but it was a very well proven car. The previous side was the car that was an early prototype that came to call. And the ubiquitous smart car. So that was a Generation 1 car that we had a couple of years ago, and that's just been relaunched again as the latest generation car. Also commercial vehicles. You've got a couple of these running around on campus already, and that's actually quite a landmark thing. So that's something that as a campus you can be very proud of. Electric commercial vehicles often, compared to cars, commercial vehicles tend to have much more defined roles. They tend to only do a certain number of miles in a day, they operate in a certain geography, or they run along a certain route. So commercial vehicles are actually a better bet to tackle first as an organisation goes rather than cars. And This one I put in, this is Renault's Fluence car, which actually had the distinction of having a battery that could be swapped. So if you think like a cordless drill, you can unclip a battery and clip a new one in quickly. There's a network of stations in Denmark that you can drive into in one of these. It looks like a car wash, and in under 60 seconds it can swap the battery for a fresh one. So it's kind of got that's one solution to having sort of unlimited range and limited mobility. And this is the Twizy that's outside. So this is one of the ones without any doors at all, but I definitely prefer it with doors. Windows are still optional, but we'll skip over this. We'll come and look at Twizy outside because it's easier. This, coming back up to that, this was in the height of the summer that we had a show over at the Heartlands at Poole, just across the road from our office, where we had all of the vehicles that are on the market displayed together. And that's what we tend to do from our public-facing side, is to actually not so much sell vehicles, but it's just to educate people about them. So we can take people across any brand of vehicle. They're all different sizes, which is kind of what you'd expect from any other normal car, but they've also got different attributes in terms of charging time, where you can charge them, how you can charge them, different range, different technologies. And there are, of course, some exotic ones out there. So the Tesla Roadster, which was launched a few years ago, and it was sort of in the order of 90 grand plus, but it was the pinnacle of technology. It was actually engineered from a Lotus Elise chassis, so again, something to be very proud of as Brits, to say that we had a hand in the evolution of that. And that is actually a genuine number plate. This is my friend's car in Sweden, and you can pick any number plate you like out there, so you pick no CO2. And this is Tesla's latest car, which has just gone on sale in the UK. So if you've got 50k burning a hole in your pocket, I can recommend it very highly. So again, it is the pinnacle of technology embodied in an electric vehicle. It's also, although it looks fairly conventional, the sort of the ratios, the design ratios of the vehicle are not dictated by engine, people, boot space. So there's a boot under the bonnet there. All the battery and all the drivetrain is in the first sort of 6 inches of the chassis. So it's designed to look conventional and not to look too scary, but it's very, very interesting the way that they've designed the architecture. When they were putting it through the North American federal crash testing tests, the equivalent of our Euro NCAP test, they actually broke the test machine. They have to test it for how many Gs it can cope with. So basically, if it can withstand 4 Gs, it would be 4 cars stood on top of each other. And they actually made it so strong it broke the test rig. So they're quite proud of that fact. But also, whilst we deal mostly with purely electric cars, so just battery cars that don't have any kind of combustion engine at all, there are vehicles out with different combinations. So this is Vauxhall's Ampera, which is also made by General Motors. So you can also find it's the Chevrolet Volt. And it is an electric car. You do plug it in, you do charge it. You only get about 40 miles as an electric car, but you've also got a small petrol engine which can kick in to act as a generator. So it's not an engine driving the wheels, it's an engine generating the electricity to keep the electric drive going. So you can have another for 300 miles on a tank full of fuel. So basically, the way that car's been laid out, you've got a battery down the spine of the car, which does make it only a 4-seater, and then you've got the engine and the electric drive where you'd expect to find it under the bonnet. It's not got that space to itself now. BMW's car that's just launched, you can get as an purely electric version, or one with a range extender engine. So it'll be interesting to see what customers go for, what they treat it as. Do they only want it as that second car that can do just does the local trips, or do they want a car that can do more?
So can we ask you anything?
Yeah, sure.
Is it a trade-off? So if you get rid of the engine part, do you then get a bigger battery? So does electric better, or is it just simply the additional petrol engine, so added weight?
BMW's i3 is the best example of this, because if you buy just the purely electric version, the battery is always the same size, so you get a range of about 90 miles as the purely electric version. If you get the version that's got the range extender, basically you'd have a hole in the car somewhere if you didn't have the range extender. So you actually, because of the extra weight you're carrying, it's only a 600cc engine, but the extra weight of the engine and the fuel tank, etc., you do lose some of your range because you're hauling around more weight. And also, you don't have, it's actually unlike the Ampera. The Ampera is designed that you can do your commute every day, short distances fine, but you can randomly drive to the Midlands and not really think about it. Whereas the i3, you can only do about another 80 miles on fuel before you'd have to fill it again. So you still don't want to use that for a long trip. It's not designed for that. But it does mean that you can more comfortably run near your limit without panicking, or in the absence of charging infrastructure as well, and especially quick charging that we'll come on to. We expect that most people are going to take that option. And it comes down to economics. You can buy, not favouring any brand, but you can buy the pure electric one for 25 grand, or you can buy the one with the range extender for about 29. So we kind of think people will probably go for it anyway. And when they come to resell it, if you can sell it as the one that's got the safety net, they'll probably sell more. I think at this point anyway. So consumers are getting more educated around what vehicles can do anyway. So, yeah, no, do feel free to jump in with any questions. Mitsubishi's Outlander, an SUV, love them or hate them, which has been around for a few years as just a straight diesel or petrol version, is now short. It's not a very good slide. It's now shortly going to be an electric extended range version as well. So it's going to have the electric drive from the smaller Mitsubishi car on each axle, with a battery, but with a fuel tank as well. So you can drive for about 35 miles as an electric vehicle, but then again the range extender engine can kick in, so you can have an infinite range from that. Interestingly as well, this can be quick charged. So even though you've only got a 35-mile range, because you can get the charge into it quickly, in the right areas with the right infrastructure, you may still want to charge it rather than using fuel. It just depends on your circumstance. So it could be a very flexible vehicle. So again, it's important to see that the engine, the generator, the engine drives the generator. It doesn't drive the wheels. So that also lets the engine run at a very optimal RPM. So you can, a combustion engine works really well within a narrow rev band, and so the engine can be optimised for weight, etc. So you can actually have a very efficient engine to generate the power. So moving on quickly to what the government in the UK does towards electric vehicles and where that sits within government. The Office for Low Emission Vehicles, which is made up of the Department of Transport, the Department for Energy and Climate Change, and the Business Industry Skills Department, they, for the last 3 years, have had a raft of incentives in place. They give you 25% up to £5 grand towards the purchase of a car, 20% up to £8 grand towards the purchase of an electric van. These all have to be qualified, so they have to appear on the approved list, which basically just states that they're of a good quality, that they go a certain distance, that they've got good warranty, etc. They also administer the plugged-in places scheme, which I'll come back to in a minute, and they also now administer a new grant scheme as well. Plugged-in places was the scheme a couple of years ago that we approached the government for, in saying that we thought Cornwall would be a good area to do this. There has been an assumption that electric vehicles are always an urban solution. We've kind of broken the mould down here in Cornwall because we've actually helped a local dealer to be very, very proactive, and they've actually sold a lot of vehicles. But these are the 8 areas that got the original funding a couple of years ago. And they've had varying degrees of success in actually rolling that out, and the consequent number of vehicles that have been adopted. The new funding scheme, I've got the details with me for how this stacks up. That's no longer attributed really to areas. It's actually being led by demand. So there's 4 schemes. One is funding home charging points. So rather than just plugging it into a wall socket, you actually have a dedicated charging point. One of the other streams is about rapid charging, and we think this is really important along the strategic route. So from the southwest, it would be the A30 towards the M5 or the A38 through South Devon, giving people, knowing that people can stop and charge in a relatively short period of time. It time enough to have a cup of coffee, you can have most of your charge back. And then some other programs for the public sector and for train stations, so to enable multimodal travel. So you can drive your electric car to the station, park it and charge it while you take the train into work and come back and do the reverse on the way home. Other incentives. In London, electric vehicles don't pay the congestion charge. They have to register, but they don't pay the daily charge. So again, if you're running vehicles in London or travelling into London regularly, you can clearly save a lot of money on operating them. As company cars, you don't pay benefit in kind either for the next 18 months or so. So normally getting taxed on the vehicle would obviously have an impact because it's considered to be part of your income if your business gives you a car. The Treasury doesn't consider an electric vehicle to be a perk at the moment, so it does mean that the effective overall cost comes down. So moving on to the practicalities of charging them, what I'm showing there is just the example of just using the cables to plug it into a standard socket. This is a typical home charging unit like the one that we now supply as well, which is wired onto its own circuit, but effectively it's just normal mains. It's just 240-volt mains as you've got coming into your house. So most electric car drivers, owners charging at home, will have that kind of setup so that when they get home, be it in a garage or on a driveway, just jump out of the car, grab the plug, put it into the car, and you're done. So effectively, that's it. So it's very, very simple using. It also almost becomes automatic. That I have got, because I've driven these cars myself for years. I'll be getting ready for bed and I'm forgetting whether I plug the car in or not, because I've got home, got out the car, put the plug in it, and it's just completely automatic. So charging at home is actually really convenient because you've got a whole overnight period, which we'll come back to is beneficial for the grid as well. But it's a relatively straightforward process, and I'll probably spend less time charging my car than someone else spends at a filling station. So overall, we add it all up. This is typically what public charging points have looked like. They're typically posts, pillars in the ground that have got a socket on them. So you take your own cable along to the charging station. If you've got a full-size car, that end is now a universal connector for the charging point, and that end depends on which car you've got. There's a couple of different standards out. There's a bit of a VHS Betamax or DVD Blu-ray fight, but that also has relevance to where those vehicles have come from or been developed in the world. This picture is a few years old. In fact, no public charging point now is going to have that top picture. Is a standard 3-pin plug, and that's not going to be used anymore. The ubiquitous 3-pin socket is fine for domestic appliances and mobile phone chargers, and God knows we've got so many of those, but you can't bring a lot of power through it. So whereas these new connectors can handle a lot more power, so you can charge vehicles more quickly. So again, these are just various configurations on cars. This is on the Nissan Leaf, and it shows why vehicle design or electrical design is going to be different in different parts of the world. On the Nissan Leaf, you've got your standard charging at home, which uses this connector, which is fairly slow. It's a few hours to charge. The big connector on the left is the quick charging, which in the case of Leaf is DC charging. So you've got a big unit to produce the DC power, and basically you see those two big connectors, it basically goes straight to the battery. So other cars can charge in a different way, and this really comes down to the fact that the grid, at least the consumer grid in different parts of the world, is different. And historically that hasn't been a problem for laptops and for every other device we've got. But when it comes to the kind of power levels you talk about for a car, it can certainly make a difference. So looking at how much power you can get into a car really governs sort of how quickly you can charge it, or what your the autonomy and your range can be. So looking at how quickly you can charge and how far you can go. Overnight charging is generally never going to be an issue. You're going to have enough time to charge a vehicle overnight, so you start off every day with enough charge in. But generally, if you're looking at a normal domestic socket, you're down around here, so the amount of power you can transfer is very, very minimal. And the extra range you get for that is pretty minimal as well. So when we look at single phase power, kind of typically what we get in our homes, you quickly hit the limit of what you can do with that. the UK and Europe, most of Europe, the UK and European power grid is generally designed as three-phase anyway. So with three-phase, you can then also get basically 3 times more power for the same standard of connection. And on the right vehicle, you can actually get a lot more power recovery in a very short period of time. But to go beyond that, you need to have a lot more power. And most vehicles then currently have always moved towards DC charging. So you're not talking about turning up something on a cable. It's going to have to be a dedicated installation that's been coordinated with the grid to know that the grid can supply that much power. This is typically what one of these big DC chargers looks like. So you've got a lot of power electronics in there to provide the power to charge the car. That's on Nissan's own charger. So Nissan dealerships that sell the Leaf have these as well. So they can you can go into there, whether it's your dealer or another dealer, and charge for free. And you're looking at about half an hour to get to 80% charge. This is Renault's Zoe, which has kind of made people rethink how you can charge vehicles quickly. Because under the bonnet of the electric car, you've got lots of electronics which govern feeding power to the motor. And when you want to go downhill and slow down, you can use energy coming from the motor to charge your battery again. Well, some bright spark, pardon the pun, decided, well, why can't we use the same power electronics to charge the car as well? And they managed to do it. So you can charge Zoe from little more than a big three-phase power supply, so you don't need the bulk and the expense of that off-board charging unit. The car does it itself. So you can still have limitations on getting at that much power, but it's a lot easier to find, a lot easier to provide than it is for other vehicles. So that was as techy as I wanted to get. So really, for you guys, I wanted to sort of mention really the carbon intensity and looking at, we know that electric vehicles are zero emission at the point of use. Okay, if they're a hybrid or any kind of range extended vehicle, there is going to be some emission, but we're generally looking at zero emission vehicles. But we know that if we're looking at a whole life cycle analysis, a well to wheels analysis, then there's obviously going to could be upstream emissions from that, from how you generate the power. And that really depends on where you're charging your vehicle. If you look at the carbon emission labels for a normal vehicle, pretty much anywhere you use that vehicle in Europe, it's going to have a very similar performance. Okay, it's going to vary in time of year and different fuel grades, etc. But largely, you know what the CO2 impact of the vehicle is going to be. Where you get your energy from is going to govern that for an EV. So Norway having lots of hydropower, Denmark having lots of wind power, they've got very clean grids. And we'll come on to mention how electric vehicles can actually help that get even cleaner. France, very nuclear, very pro-nuclear, heavy degree of nuclear power on the grid. In fact, if you recall the early vehicles I showed you, the Peugeot 106, Peugeot partner van, Citroën and the Citroën equivalents, the reason that those vehicles even existed was the fact that the French wanted more nuclear power, and the only way they could justify having more baseload at night was to generate the demand at night. So by supporting electric vehicles, they would know then that they would have more demand at night. When you charge the vehicle, definitely makes a difference. So if you're charging in the peak of the day when all the other activities going on consuming power, well, you're going to have a greater carbon impact as well as maybe reaching the capacity of the grid. So off-peak charging when other activity, other electrical loads aren't in place, certainly lowers the overall demand. But of course then, if you can look at any kind of local micro-renewable or grid-connected large-scale renewables, then that's clearly going to have an impact as well. So, my figures may be a little bit out of date. If that ballpark sounds about right, that for the UK grid, we're looking at around 450 to 500 grams of CO2 per kilowatt hour generated as a very broad average across all the different generating formats that are on the grid. So when you look at how many miles, how many kilometres, what distance you can get from a given kilowatt hour in an electric vehicle, and of course that's very efficient. Electric vehicles can convert about 90% of that energy that you put into them into motion, whereas a fuel vehicle would be anything between about 25 and 50%. So you lose a hell of a lot of energy for every litre of liquid fuel you put into a vehicle. Doing the sums, you end up with a CO2 per kilometre figure of about 100 grams of CO2. Now you can get conventional vehicles that can match that in terms of using the fuel directly. So, you know, if a fleet or an individual is just looking at taking an electric vehicle and just not doing anything to control where they get their energy from, you know, you've got to argue the merits of actually doing that, whether it's worth doing. But when you look at the combined cycle gas generating plant that forms a large part of our baseload supply, and that is actually very much lower than the average figure, it then starts to look a lot better. And some of the smaller vehicles have then got an equivalent figure of around 50 grams CO2, and that's still assuming that we're not using any renewables. For myself, I happen to be with a supplier which buys all their energy from Delapole Wind Farm in North Cornwall. So, you know, not least because of kind of the role I've got in business, that I can say effectively my vehicle's being run from a Cornish wind farm.
So that means more expensive if you buy that electricity?
Marginally, it's not massively so. They've also, this particular supplier, have also just introduced a reduced tariff for people living within Cornwall or within the southwest. And if you live, yeah, energy gas, yeah. And they've got, I mean, and if you live within Delapole, if you live within 2 kilometres of the site,
kilometres or something, it's 20%.
you get it cheaper,
discount.
yeah.
But you have to change over to their tariff if you want a discount.
Yeah, yeah. So yeah, so it is slightly more expensive, but that also means my house has an economy 7 tariff, and I'm off the gas grid, which we'll come on to as well. So I've got cheaper energy overnight anyway, and I just move everything else I can, like so I run the washing machine at night. So it's, yeah, I'm paying a bit of a premium, but I still think it's worth it to make sure that I'm minimising the impact of the vehicle. Just to put it in context, often when you, I don't know if you can tell from that scale it is, often we see solar farms described in the number of homes equivalent, and I always find that really hard to picture. Maybe it's just me, but that a 5 megawatt solar farm is the equivalent in transport terms of around 1,500 cars doing 10,000 miles a year. So I like to use that as a kind of benchmark to say, okay, well, you know, whatever your opinion of large scale solar farms, that is equivalent what it can do. So, you know, 1,500 cars, the cars in your village or part of your town doing average mileage could be catered for by a solar farm of that size. So it's just another metric to use to describe it. But looking at the demand, looking at the peak demand, again, I can't imagine, even though these figures are slightly out of date, I can't imagine that things have changed massively on the UK grid. There is this massive trough overnight between midnight and when we all start to get up, which is very low demand. Of course, it varies. It's got seasonal variation as well because there is some extra heating demand, etc., from off-peak storage heating overnight. But this massive trough overnight compared to the sort of standard load in the daytime is all available to us effectively. We definitely don't want to be charging during the peak demand of the early evening when everyone's cooking dinner in the winter. But this opportunity here is where we can charge a lot of vehicles. So 8 to 10 gigawatts of capacity for 7 hours. So let's say in very round terms we've got 60 gigawatt hours overnight, most nights. 12 kilowatt hours into a vehicle. I mean, the vehicles can hold more than that in terms of energy. I'm just saying what typical usage would be. That's equivalent to 5 million vehicles doing a 40-mile commute every day. So there's a lot, you know, we're at 6,000 vehicles currently under the government grant scheme. That's picking up. 1,200 of those vehicles came in the last quarter, but we've got a hell of a long way to go, both in terms of decarbonising our vehicle fleet overall, but we've still got plenty of capacity to deal with them. That's in the big picture though. That's kind of looking at it as a nation. If we're looking at it locally, there are areas, there are parts of Cornwall, in this case, you know, West of Penzance doesn't have a gas grid. The Lizard Peninsula doesn't have a gas grid. So what might happen, will we get pinch points on the local grid to where to how many vehicles we could support and what reasons, what combination of factors might affect that. So off-peak charging is definitely where we want it to be. We don't want people plugging vehicles in the daytime unnecessarily if it can wait till night. But where you are off the gas grid, you can have areas where the peak demand actually comes at night. Western Power Distribution is the local distribution network operator, the DNO, are very conscious of that. And certain parts of Cornwall and other rural areas, particularly around the country, could have issues with having a lot of demand overnight. So you might need to get smarter at doing that. I'd like to think that the people buying vehicles are going to be very much dispersed and it's going to be quite random. But actually you might find that you've got people keeping up the Joes that actually like to think it's more that they're positively influencing their neighbour rather than the neighbour negatively trying to run up them. But we can look at what's the best strategy to charge a car. If you need to put 10 kilowatt hours into a vehicle, should it be, if you can do it, to do that in 1 hour between 3 and 4 in the morning? Or is it actually better to spread it out and charge it between 12 and 5 at 2 kilowatts? I mean, we don't know. There's actually some work going on right now, a project called My Electric Avenue, which is actually, it's looking at what happens if we give a community a bunch of cars. Will it sort themselves out? Will they sort themselves out? Are their lives different enough that they'll be charging them at different times of day? Or does everyone come home at 6 o'clock and plug it in straight away and basically force it to charge then instead of waiting until overnight? So it'll be interesting to see what the results of that conclude. My personal belief at this point is that we haven't done enough to try and head off those problems. So we'll see how it goes, whether it is just needs a very light touch and things will work themselves out or not. But demand side management, I think, is we are going to get to a point where we've got to be a bit smarter about how we do this. We do need to not necessarily control how vehicles charge, but just to incentivise when they do. So giving people the choice to say, okay, well, you've only got a 5-mile commute to work and back. Well, you can charge your car one night a week. Well, can you give us control when you do that? So you get home every night, you put the plug in it, but every morning, we guarantee you'll have enough to go to work and back. But we can control, the grid, can control when we charge your car in relation to what we're looking at in terms of predictions of energy, particularly with renewables. This was, I forget what football match this was, but this was a slide that showed how when a football match went into extra time, how they had the pickups, the extra demand. And this is the very British phenomenon of making a cup of tea in the at half time and at full time during penalties, etc. And the same thing happens every day actually. It'd be interesting to see how this changes now with people watching stuff on demand and on catch up. But the ad break in Coronation Street, still one of the most valuable pieces of equipment in the National Grid control room is a little 14-inch TV, 14-inch colour TV, which tells them when the ad break's coming up or when the doom-tools at the end of EastEnders kick in, and everyone goes and switches their caps on. So apparently it's just a very peculiar British phenomenon. You may remember this is the battery from the Nissan Leaf. One of the things that will happen in time, there's no Nissan Leaf as one of the earliest cars out there. None of them are over 2.5 years old at this moment. So we're still expecting many years before the batteries in the vehicles start to get tired and may be taken out and replaced. That's not to say that the battery's dead, it's just that it hasn't got as much capacity as it had when it was new. So maybe people think, that's not practical anymore, I want a new one, maybe I'll take a better, newer, advanced battery chemistry that goes further on the charge. Well, what do we do with that? Do we just want to reprocess it and recover all the metals, recycle it? What Nissan have suggested, I don't know why that keeps fading that much, but you might be able to see there's actually 4 of these old batteries. They weren't old because we didn't have any old ones. To put them in a case, plug them all in, and that becomes a backup power supply for a computer server. So again, because the battery's at 75% of its original capacity, that's not an issue for that application. So again, they'll spend 7 years in this application, and then we'll recycle them and recapture our recovered metals. Vehicle to grid is another extension. This hasn't been done commercially yet. You can imagine the scenario where you've driven your modest commute, you've come home, you've put the plug in your car waiting for tomorrow morning, but there's actually some energy still left in your car, the car could actually give that to the grid as well. So you may not want to give all of it. It may not do the battery any favours to give all of it on a nightly, on a daily basis. But looking at what we've had to build into the grid to deal with phenomena like the 20 million kettles and other effects, it's an orbit power station that can crank up to 1.3 gigawatts within 12 seconds. Well, if we had 60,000 Renault Zoes that were capable of doing that, or 200,000 vehicles even with a standard domestic connection that could export energy, none of the vehicles currently on the market can do it anyway. If they could, we'd only need 200,000 vehicles to match the output of one of the biggest reserve power stations in the country. There's 26 million vehicles in the UK, so we'd only need a fraction of that vehicle population to be electric, but capable of interacting with the grid to be able to do that. And if we were covering that outbreak, 5 minutes dumping some energy back into the grid would be such a small part of that battery's capacity. It would barely age the battery at all. It would be imperceptible what that would do to the battery. So again, this isn't commercial yet, but we know it can be done. It's been done in certain sort of small projects, certain trials. In Japan, after the Fukushima incident, Nissan with the Leaf and Mitsubishi also, they were developing products which they could plug into the car so you could run appliances from the car. And really it was a bit of a novelty. It's just the fact that, yeah, you can drive out to the middle of nowhere and still, cook dinner. They've shown pictures of it using a rice cooker. But actually this came to its own and they rushed these out when Fukushima happened because the power grid was so dodgy for such a long time because they had to take a lot of the nuclear plant offline. So it kind of forced the issue. It was small scale. It didn't feed it to the grid. It just meant you could just go and plug in appliances to the car in a completely separated system. So that's me. That's us. If you want to follow us or catch up with us on Facebook or Twitter, you can. It's always just basically EcoDrive EV. And those should be on the contact page. There we go. There's my email, phone number, etc. So, are there any questions?